Welcome back. This is the third and final video in the ground bearing pressure series, and in this one I want to talk to you about outrigger pad types and the effects that can have on ground bearing pressures. Looking at this is a fairly common type of thing that you'll see around the place. 5 timbers on the ground, 3 across the top. Timbers generally around the 1 or 1.2 metres long and 250 wide and about 75 mil thick. So looking at that, you would have a ground contact area of 1.2 by 1.25. Now that would give us 1.2 times 1.25, a ground contact area of 1.5 metres, or so the thinking goes. Now, before we look at what can be the actual pressure, I just want to talk about other factory designed outrigger pads. So this is the table of Liebherr outrigger pads, and these are engineered steel pads, and by that I mean something like this. So you'll see inside this pad there's all this extra gusseting and plates, and the whole idea is that the outrigger jack must be centered on the plate, but the plate is designed to act as a bridge. That is, it can be supported only on one edge and only on the other edge, and it will still support the crane. In the case of the Liebherr pads, as you can see on some of the bigger cranes or some of the bigger pads, you'll see this is what I'm talking about, the pad acting as a bridge. So this is C, in column C, up to 450 tonnes on some of the Liebherr pads. The pads are enormous. They're 6 metres long, 2.4 wide, 300 mil high, and they weigh 14.4 tonnes. So sorry, they're 14.4 square metres, they weigh 7.6 tonnes. So these are very big, heavy, engineered pads, right? So when you've got pads like this, engineered pads, when you're calculating ground bearing pressure, you can take the entire surface area of the pad. So on the Liebherr document, you can take these numbers as the ground contact area, okay? Now, when we're working with timbers, it can be a different kettle of fish. Because we can't specify the strength of these timbers or when they might fail, we have to work on what's called a zone of influence. So lines of force will radiate out from the crane outrigger pad at 45 degrees. And I've looked at this in another AutoCAD that I have, which is the full version of AutoCAD. It's a 3D program. So I have drawn these typical pads up in 3 dimensions, and if I go to a different style X-ray, you'll see that I've worked out, taken those lines out at 45 degrees down through the timbers, and that's given me that contact pad. So that I've turned into a polyline, which means now I can go to Tools, Inquiry, Area, and click on that, and the command line is telling me that pad is about 0.95 of a square metre. Okay, 0.95 for a rectangle pad like that. If we go to a round pad, and I've done a similar thing here, I've worked out the lines of force down through the timbers, which gives me that circle. This is with a crane with a circular outrigger pad, and so I can do the same thing again. Tools, Inquiry, Area. The area of that circle is about 0.63 of a square metre. Okay, so the square pad's 0.95, circular pad's 0.63. Now that's important when we go back to this drawing. I want to show the effect that can have if you only consider the zone of influence under timbers. So if you take the full rectangular pads, we take the full surface area of 1.5 square metres, and I allow 0.1 of a tonne, 100 kilos for the weight of all the timber, and the jack force is 50 tonne. That would give us about 328 kPa, right? If we only look at the 0.95 square metres with the zone of influence, that goes up to 517.3, increased from 327. So that's a pretty significant increase. It gets far worse when we look at circular pads. Again, if you put a circular crane pad on top of 5 timbers and use the 1.5, some people will tell you you've only got 327 kPa. However, the very worst case is that zone of influence at 0.63 of a square metre, and now we're up to 780 kPa. We have more than doubled. So the true figure will lie somewhere between those two. But unless someone can quantify exactly when that timber will fail, it'll depend on whether they're hardwood, softwood. Obviously it depends on how hard the ground is underneath. So as I say, the true figure, it would lie somewhere between these. As a lift planner, it should be your duty to advise your client of the worst possible case. So this is what I would be telling my clients. This is the worst possible. Now this would be considered very, very high pressure. So to mitigate that, you would need to start looking at different pads. You would either start looking at things like the Liebherr pads, or the only other way to decrease pressure with timbers would be to have higher stacks. So the higher you stack, or the more layers of timber, that zone of influence will grow and will start to reduce. But the main point here, I just want to make you aware, be very careful of which ground bearing pressure you give your clients. Always give them the worst case. And that's ground bearing pressures finished. Thank you.